All right, so this lesson is about the quadratic formula. So we've looked at a couple of methods so far to solve a quadratic equation, solving something like x squared plus 11x plus 30 equals 0. We can factor this as x plus 6 times x plus 5 equals 0, and then set each individual factor equal to 0. Okay, so that's solving by factoring. Okay, and then if we also had an equation like, I don't know, 2x squared equals 50, okay, we can divide each side by 2, x squared equals 25, and then we can take the square root. Remember, put a plus minus in front of the 25. When you take the square root, and go x is plus or minus 5. Okay, so this is square rooting. Okay, but sometimes you get a quadratic equation where it's not possible to factor and it's not possible to take a square root. So we're going to use the quadratic formula to solve a quadratic equation if factoring or square rooting is not possible. Okay, so the quadratic formula, and you saw it last year, at least a little bit. Here's your quadratic formula. X equals negative b plus or minus square root b squared minus 4ac all over 2a. Okay, and the values of a, b, and c come from here. Ax squared plus bx plus c equals 0. All right, so let's get into example. I want to start by identifying the values of a, b, and c, so then we'll have everything we need to substitute into our formula. So for number 1, a is 3, b is 2, and c is also 2. Remember, ax squared bx plus c. The a is just the coefficient of the x squared, again, which is 3 here. The b is the coefficient of the middle term, the x, which is 2, and c is your constant term. All right, so if I tried to factor this, right, the factors of 2 or 2 and 1, there's no way from 2 and 1 to also make it add to the middle term, the 2 here. So that's why we're going to use the quadratic formula. Okay, so if we start setting it up, here is your quadratic formula. It's always a good idea to keep writing it out. All right, and we'll substitute. So negative b, so that's going to be negative 2, plus or minus the square root of 2 squared minus 4 times 3 times 2 over 2 times 3. Okay, so let's go up here. So we've got negative 2 plus or minus square root of 4 minus 24. So we got negative 20 inside the square root, which means we're going to need I over 6. Okay. So we got negative 2 plus or minus. We can simplify square root of negative 20 by using the pair 5 and 4. So we can go square root of 4, square root 5, and remember you need to put in your square root of negative 1 to account for the negative inside, over 6. So we've got negative 2 plus or minus 2i square root 5 over 6. So we can split this up as negative 2 plus 2I square root 5 over 6, comma, that's your positive from the plus minus, your negative, negative 2 minus 2I square root 5 all over 6, okay? Another way you can do it, negative 2 over 6 is negative 1 over 3 plus I square root 5 over 3, comma, negative 1 over 3 minus I square root 5 over 3, okay? Either one of those are fine. Okay, number 2, again, your quadratic equation has to be in the form ax squared plus bx plus c equals 0. So let's make number 2 look like that. We'll add, let me write it again down here. So we'll bring this to the left, and we'll bring that to the left, giving me 4y squared plus 8y plus 1 equals 0. Okay, so for this one, a is 4, b is 8, and c is 1. So put everything in the quadratic formula. So x will be negative 8 plus or minus square root 8 squared minus 4 times 4 times 1 over 2 times 4. So x equals negative 8 plus or minus square root of 64 minus 16 is 48. So square root of 48. Square root of positive 48, so this one isn't going to have I in it, over 8. So we got, to simplify, square root of 48, 48, 1, 24, 2, 16, 3. 16 is going to be our largest perfect square. So we have negative 8 plus or minus square root of 16 square root 3 over 8. So that's going to be negative 8 plus or minus 4 square root 3 over 8. Okay. And you just want to separate out your answers. Negative 8 plus 4 square root 3 over 8, comma, negative 8 minus 4 square root 3 over 8. Okay, and you can divide it out. You could go negative 8 divided by 8 is 1, and then for the 4 over 8, put 1/2 square root 3, but it's not necessary. All right, so number 3, you're going to want to add that x squared to both sides, giving us x squared plus 11x minus 4 equals 0. Remember, x squared has to come first, ax squared plus bx, so your x term in the middle, and then your constant term at the end. So a is 1, b is 11, c is negative 4. So x equals negative b plus minus square root b squared minus 4ac over 2a. Yes, I want you writing it out every time you do this. All right, so substituting, that's going to be negative 11 plus minus square root of 11 squared minus 4 times 1 times negative 4 over 2 times 1. Okay, so x equals negative 11 plus or minus square root of 11 squared is 121. Negative 4 times negative 4 plus 16 over 2 equals negative 11 plus or minus square root of 137 over 2. All right, so 137 is actually a prime. The only way to make 137 from multiplication is 137 times 1. So we can't simplify the square root of 137. So we're going to write our answer as negative 11 plus square root of 137 all over 2, comma, negative 11 minus square root 137 all over 2. Okay, and the last one, we'll move that 7 over. So x squared plus 5x plus 7 equals 0. A is 1, B is 5, C is 7. All right. So, quadratic formula. So x equals negative 5 plus or minus square root of 5 squared minus 4 times 1 times 7 over 2 times 1. So negative 5 plus or minus square root of 25 minus 28 over 2. So it's negative 5 plus or minus square root negative 3 over 2. So 3 is a prime, but we need to use I to account for the negative inside, so it goes square root negative 3 equals square root of 3 times square root of negative 1, which is square root of 3 times I, and the I comes to the front. Okay, so we'll go negative 5 plus or minus I square root 3 over 2, which we'll write our answers as negative 5 plus I square root of 3 over 2, comma, negative 5 minus I square root 3 over